Suspension system of a vehicle plays a vital role in enhancing vehicle's overall performance and comfort. They are responsible for absorbing shocks and maintaining stability, ensuring a smooth and controlled ride. But how do suspension systems actually work? Suspension systems are designed to cushion and enhance the vehicle's stability. They work by absorbing the impact of bumps, potholes, and uneven road surfaces, minimizing vibrations and ensuring better tire contact with the road. One crucial component of suspension systems is suspension springs. These deceptively simple components do a lot of heavy lifting as they support the vehicle's weight while helping to absorb shocks and maintain overall ride quality. But how exactly do these seemingly simple coils help keep your ride smooth? And how did they come to be such an essential part of modern vehicles? So today, in this video, we'll look into different types of suspension spring, starting with leaf spring. A leaf spring is a simple and effective form of suspension, commonly used in many vehicles. It is typically made of several layers or leaves of spring steel bound together in a specific pattern. These leaves are progressively shorter in length and are stacked on top of one another. Forming a curved or arched shape resembling a bow, this design provides flexibility and resilience to the spring. Leaf springs, with their simple yet effective design, have been an integral part of vehicle suspension systems for centuries. Their ability to distribute weight, absorb shocks, and maintain stability make them a cornerstone of safe and comfortable transportation. Leaf springs were used extensively in the suspension systems of wagons, carriages, and early automobiles, making them one of the oldest forms of vehicle suspension. The earliest known leaf springs began appearing on carriages in France in the mid-17th century in the form of the two-part elbow spring, and later migrated to England and Germany, appearing on the carriages of the wealthy in those countries around 1750. Obadiah Elliott is credited with inventing the modern leaf spring with his 1804 patent on elliptical leaf springs, which brought him significant recognition and revenue. A leaf spring, originally known as a laminated or carriage spring, is sometimes referred to as a semi-elliptical spring, or cart spring. The shape of the spring can be semi-elliptical or elliptical, which is why it's sometimes referred to by those names. Leaf spring contains main leaf, helper leaves, and overload leaf. Center bolt, rebound clips or spring clamps, eyes, front and rear, shackles, U-bolts, spring plate or axle seat, mounting brackets, front and rear hangers, and bushings in the eyes and shackles. First, the main component is the leaf spring itself. They're made of several layers of metal called leaves. The top one is the main leaf, which is the longest and has eyes at the ends where it attaches to the vehicle frame. Then, there are other leaves stacked underneath called secondary or helper leaves. They add stiffness and support the main leaf. There's also a center bolt that holds all the leaves together. Without that, the leaves might shift around. Shackles are those metal links that connect the end of the leaf spring to the frame. They allow the spring to flex when the vehicle goes over bumps. The eyes are the ends of the main leaf. The front eye attaches to the front hanger on the frame, while the rear eye connects to the shackle. The shackle itself is near the rear end, allowing movement. Then there's the U-bolts. Those are the big bolts that clamp the leaf spring to the axle. They keep the axle in place relative to the spring. The axle sits on top of the spring, so the U-bolts wrap around the axle and bolt into the spring plate, which is a metal plate that sits on top of the springs. Also, there are bushings inside the eyes of the main leaf. Those would be rubber or polyurethane to reduce friction and noise when the spring moves. Bushings are important for smooth movement and to absorb vibrations. Mounting brackets. The frame must have brackets where the leaf springs attach. The front bracket is fixed and the rear bracket have the shackle. So, the front eye is mounted to a fixed bracket and the rear eye is connected via a shackle to another bracket on the frame. There's a rebound clip or a clamp that keeps the leaves aligned under rebound when the spring extends. These clips wrap around the leaves to prevent them from splaying apart when the suspension droops. Also, some leaf springs have an overload leaf, which is an extra leaf that comes into play under heavy loads to provide additional support. That makes the suspension stiffer when needed. The center bolt not only holds the leaves together, but also positions the axle. The axle is located by the center bolt. So when you install the spring, the center bolt sits in a hole on the axle seat to keep everything aligned. The different types of leaf springs are available, such as semi-elliptical leaf springs, elliptical leaf springs, quarter-elliptical leaf springs, three-quarter elliptical springs, and transverse leaf springs. Leaf springs offer a smoother ride and better weight distribution, making them suitable for vehicles that frequently carry heavy cargo. These springs provide excellent load-carrying capacity and stability, ensuring better control over the vehicle. However, they may not provide as much comfort as other types of suspension spring. Leaf springs were very common on automobiles until the 1970s, when automobile manufacturers shifted primarily to front-wheel drive, and more sophisticated suspension designs were developed using coil springs instead. Today, leaf springs are still used in heavy commercial vehicles such as vans and trucks, SUVs, and railway carriages. Regular maintenance, such as lubrication, is necessary to ensure optimal performance and prevent squeaking or noise. Leaf springs can be upgraded with additional components, such as helper springs or shock absorbers, to improve ride quality and stability. Coil springs are one of the most commonly used suspension springs in vehicles. They are made of a series of metal coils and are known for their durability and reliability. Generally, a coil spring is a helical spring made from high-strength elastic material, such as metal, usually steel. This design enables the spring to compress, extend, or rotate under load, and then return to its original shape once the load is removed. The properties of coil springs allow them to store energy temporarily and release it as needed. When used in vehicle suspensions, it is designed to compress and rebound under load, absorbing road shocks and supporting the vehicle's weight. So how do they work? A coil spring functions by resisting force through compression or extension. When a wheel encounters a bump, the coil spring compresses, storing energy. As the wheel moves back up, the spring expands, releasing the stored energy and helping to return the vehicle to its original position. The spring rate, or stiffness, indicates how a spring will perform under load. It is defined as the amount of load required to compress the spring by a unit of length. In heavy-duty applications, selecting a spring with the correct spring rate is essential to ensure that the spring can absorb the required forces without compromising its structural integrity or functionality. A higher spring rate indicates a stiffer spring, which is beneficial for applications involving heavy loads, but it must be balanced with the need for flexibility and shock absorption. Their stiffness can vary depending on the vehicle's design, with performance cars often using stiffer springs for improved handling and luxury cars using softer springs for a smoother ride. Coil springs first appeared on a production vehicle in 1906 in the Brush Runabout, made by the Brush Motor Company. Today, coil springs are used in most cars. A coil spring suspension can be stiff to soft depending on the vehicle it is used on. It can be either mounted with a shock absorber or mounted separately. In some setups, the coil spring is part of a McPherson strut. Also, some vehicles use coil springs with a separate shock, others integrate them into a strut. Different coil spring in a vehicles are McPherson strut, double wishbone, and solid axle with coils. A McPherson strut is a type of suspension system that's used in the front wheels of most modern cars. It combines a shock absorber and coil spring into one unit that also controls the wheel. In double wishbone, the coil spring is mounted between the lower wishbone or control arm and the vehicle frame, while the shock absorber is mounted separately or integrated in a coilover setup. This system is often used in sports cars and vehicles that require high levels of handling performance. In solid axle with coils, the springs is mount between the axle and frame, often paired with shock absorbers and track bars for stability. This design is commonly found in rear-wheel drive vehicles, trucks, and SUVs. The solid axle ensures that both wheels on the same axle move in unison. Coil springs provide excellent support and stability, making them suitable for various vehicle types, including sedans, SUVs, and trucks. These springs offer a controlled and balanced ride, ensuring better handling on different road surfaces. Coil springs in trucks allow them to ride smoothly when unloaded, and once loaded, the spring compresses and becomes stiff. This allows the vehicle to bounce less when loaded. In high-performance cars, Coil springs help absorb bumps and reduce body roll during cornering. In off-road vehicles, they are valued for their range of travel, which allows the wheels to move freely over rough terrain. The advantages of using coil springs include their cost-effectiveness and wide availability for replacement or upgrade purposes. Their durability makes them ideal for off-road vehicles or those subjected to heavy loads. Coil springs can be paired with other suspension components, such as shock absorbers, to further enhance ride quality and performance. A torsion bar is a type of vehicle suspension system that uses a torsion bar as its main weight-bearing spring. It is a metal bar that twists to absorb shocks and provide a stable ride. Torsion bar is commonly used in both the front and rear suspension of vehicles, particularly in some older vehicles, trucks, and certain off-road vehicles. The torsion bar is typically a long metal rod attached to the vehicle's frame. At one end of the torsion bar is fixed to the vehicle chassis, while the other end connects to a control arm via a torsion key. The torsion key is mounted perpendicular to the bar. This torsion key is often used to adjust the ride height, allowing for some fine-tuning of the suspension setup. The torsion key is attached to a suspension arm, spindle, or axle, depending on the design of the vehicle. The torsion bar twists along its axis under load, which means when the suspension moves due to bumps or uneven terrain, the bar experiences twisting along its length. The torsion bar resists this twisting motion due to its stiffness. This resistance creates a spring effect, supporting the vehicle's weight and maintaining stability. As the wheel moves vertically, up or down, the suspension system causes the torsion bar to twist. This converts the vertical motion of the wheel into torsional stress, or the twisting force, which the torsion bar resists, helping to absorb shocks and return the vehicle to its neutral position. The effective spring rate of the bar is determined by its length, cross-section, shape, material, and manufacturing process. Torsion beam rear suspension is used in cars that connects the rear wheels through a rigid axle. It operates on the principle of twisting or torsion. The effectiveness of torsion beam suspension depends on various factors, including the intended use of the car. For compact cars and everyday commuting, torsion beam suspension can offer a balance of cost-effectiveness and functionality. A torsion beam, usually a metal rod U-shaped or H-shaped beam, runs side to side, connects the rear wheels. When one wheel encounters a bump or irregularity in the road, the torsion beam twists, effectively transferring the force to the other wheel and allowing for a more synchronized response to road conditions. The two arms behind the wheels are connected by another bar, which also acts as a stabilizer. This setup allows the wheels some freedom, but they're still connected by the bar. It's not exactly like a solid axle. It's a bit more flexible. Torsion bars were widely used in trucks, military vehicles, and older passenger cars, particularly Chrysler models from the 1950s to the 1980s. They are still found in some off-road and heavy-duty applications due to their durability and ability to handle heavy loads. However, modern sports cars rarely use torsion bars. The first vehicle to use torsion bars was Leyland 8, designed by J.G. Perry Thomas and produced from 1920 to 1923. But it was more of a torsion bar-assisted system rather than a full torsion bar suspension. In 1923, Perry Thomas patented an updated design featuring a true torsion bar design with no leaf springs. However, the inventor's death in a car crash in 1927 prevented its further development. Therefore, the invention is often credited to the Porsche GmbH, which patented it in 1931 and later used in a lot of designs. Torsion springs offer excellent handling and responsiveness, making them ideal for performance-oriented vehicles. These springs provide precise and controlled suspension movement, enhancing cornering ability and overall driving dynamics. However, they may require more maintenance and adjustments to ensure optimal performance. Air suspension is a type of vehicle suspension powered by an electric pump or compressor that pumps air into flexible bellows that are typically made out of a textile-reinforced type of rubber. Unlike hydro-pneumatic suspension, which offers many similar features, air suspension does not use pressurized liquid, but pressurized air. The air pressure inflates the bellows and raises the chassis from the axle. An air spring in air ride suspension is a rubber bellow that inflates with air to raise the vehicle and deflates to lower the vehicle. An air spring can be found on an air strut or by itself, depending on your suspension setup. On an air strut, the air spring is at the top of the strut and acts similar to your factory suspension setup. Instead of a strut and coil spring, the air strut features a strut and air spring. Air struts are vehicle-specific, so you will need little to no modification when installing them on your vehicle when switching to air suspension. Air springs provide excellent shock absorption, minimizing vibrations and improving overall ride comfort. They provide a smooth and adjustable ride, allowing for customization based on load capacity and desired comfort. Air springs are commonly found in luxury vehicles and RVs, offering a high level of comfort and ride quality. However, they may be more expensive to install and maintain compared to other suspension spring types. Like most new technology, air springs actually date back a lot further than we may think. First invented in the early 1900s, air springs were produced and featured in a handful of luxury automobiles and heavy-duty equipment such as military and construction vehicles. Regular inspection and maintenance of air springs, including checking for leaks and proper air pressure, are necessary to ensure optimal performance. When selecting suspension springs, several factors should be taken into consideration. Firstly, the vehicle type and purpose play a significant role in determining the appropriate suspension springs. Different vehicles have varying weight distributions and handling requirements. For example, a heavy-duty truck may require leaf springs to handle heavier loads, while a sports car may benefit from torsion springs for improved handling. Secondly, the desired ride quality and comfort should be considered. Some suspension springs may offer a stiffer ride, providing better responsiveness and control, while others provide a more comfortable experience with smoother damping characteristics. Understanding the balance between ride comfort and handling performance is essential in choosing the right suspension springs. Load capacity and weight distribution are also vital factors to consider, especially for vehicles that frequently carry heavy loads. Suspension springs should be selected based on their load carrying capacity to ensure optimal vehicle performance and stability. Additionally, the distribution of weight between the front and rear of the vehicle should be taken into account to achieve proper weight balance. Lastly, cost and maintenance considerations should be evaluated. Different suspension springs may vary in terms of initial cost and long-term maintenance requirements. It is essential to weigh the benefits and drawbacks of each suspension spring type against the budget and maintenance capabilities. And there you have it! Now you know exactly how your car's suspension springs work tirelessly to keep your ride smooth, stable, and safe, whether you're cruising down the highway or tackling a bumpy back road. From the rugged reliability of leaf springs to the precision of coil springs, the adaptive genius of air springs and the clever twist of torsion bars, each type of spring is a marvel of mechanical engineering. It's a system born from centuries of innovation, evolving from horse-drawn carriages to today's high-tech vehicles. The next time you hit a pothole and barely feel a thing, remember, it's not just metal doing the work. It's the perfect blend of physics, design, and some serious automotive ingenuity.